Alright guys, so at the tail end of 4.1 you filled in this chart that talks about each sequence from 4.1, and the main thing I want you to look at in this chart that's kind of leading us into our 4.2 lesson is, I'm going to color code and see if you can see the connections here. Okay, what do you notice about each of these sequences? What you should notice is that you're either adding or subtracting the same number to each term. Okay, I'm always subtracting 4 in positive thinking. We were always subtracting 6 eggs in Al's omelets. Gamer Guru, adding 50 to each term. Polygon Party, we're adding 1 side to each polygon. Okay, so those are all special because we're always adding or subtracting a number, and those sequences have a special name that we're going to talk about. They're arithmetic sequences. Okay, then let's look at the next category here. Okay, in this category, and are we missing one here? Because I feel like I highlighted 3. Nope, guess not. These are all we're multiplying by something. We're multiplying. Now, I know at the pizza contest one, it says multiply by a half, and then in parentheses it says, or divide each term by 2. Well, guys, in sequences here, let me find the page I want to find. What you have to realize is that division is not going to really work out for us in our sequences. We're never going to talk about things in terms of division. We're always going to flip it to how can we talk about it in terms of multiplication. So dividing something by 2 is the same as multiplying by 1/2. Okay, dividing by 2 or taking half of something are the same thing. Dividing by 3 and multiplying by 1/3 are the same thing. Dividing by 10 is the same thing as multiplying by 1/10 or 0.10. So all of these sequences that multiply by something, they're a special type of sequence called a geometric sequence. And then the rest of these sequences, they're patterns. There's no doubt that there's like a pattern to it. But they are not arithmetic or geometric. They are neither one. So an arithmetic sequence, and guys, I'll be honest, I'm not 100% sure I'm even saying that right, but that's not the point. Okay, in an arithmetic sequence, it's a sequence in which I don't like the wording that they use. Okay, it has a common difference. All right, basically it's a sequence where you're either adding or subtracting the same number over and over and over again. Okay, and the common difference is represented by the variable d. So an example of an arithmetic sequence would be if I started with 5 and, let's make that, added 3 every time. Okay, that would be an arithmetic sequence. And I'm adding 3 every time, so we would say that the common difference, or d, is equal to 3. If we were subtracting the same number over and over again, okay, so for example, if I took a different sequence, if I started at 7 and then 3 then -1, then -5. Okay, my pattern is that I'm subtracting 4 every time. So my D would equal -4. A geometric sequence are those sequences that are multiplying by the same number every time. Okay, I don't like the way they word it here. Okay, so the number they are multiplying by is R. So I'm going to make this a little bit simpler for you. Okay, if I started off with 2, and then my next term was 6, and then my next term was 18, and then my next term was 54, the pattern is I am multiplying by 3. And R for ratio equals 3. Now, tricky, because division is but is not part of this. Yes, it is, but we don't say the pattern is divide by 5, okay? Let's say I started at 625. I divide by 5, and that's 125. And I divide by 5, and that's 25. And I divide by 5, and that's 5. And I divide by 5, and that's 1, and so on. I know it's tempting to write the words divide by 5. But we always have to talk about this in terms of multiply. So we are multiplying by 1/5. Multiply by 1/5. So my R equals 1/5. We're always going to talk about it in terms of multiplication. It's easy with subtract. We can just throw a negative sign in front of it. We can't do that with multiply divide. Okay? So we have to talk about it in terms of multiply, but we're going to take the 5 and flip it into a fraction. Okay, then the next activity in class was to take these cutouts. We're not going to cut them yet. Your homework is to cut them and have them ready. We need them ready for not tomorrow, but 2 classes from now. We're going to go through each one, and we're going to determine, is it an arithmetic sequence, is it a geometric sequence, or is it neither one? Okay, they're all going to follow some sort of pattern, but that doesn't mean they have to be arithmetic or geometric. Okay, so I will tell you that sometimes it's hard to figure out what kind of sequence that it is. So here's things to try. All right, on your calculator, or if you get stuck on one, either on your calculator or in your head, try to see if I work backwards through the sequence. If I do 360 and I subtract 180, okay, if I subtract those, I get 180 by subtraction. If I do 180 minus 90, I get 90. Well, those aren't the same, so it's not a common difference. They don't have the same number when I'm subtracting. And remember, we're going backwards through the sequence. That's why I'm saying subtract instead of add. All right, so subtracting did not work. Well, now I'm going to try division. Okay, 360 divided by 180 is 2. 180 divided by 90 is also 2. And 90 divided by 45, 2. So because division worked going backwards, then multiplication by 2 will work going forwards. 45 times 2 is 90. 90 times 2 is 180. 180 times 2 is 360. So we figured out the pattern is multiply by 2. Multiply patterns are geometric patterns. The number you multiply by is your common ratio, your R. Okay? B. Pretty easy to see B. All right? we seem to be going up by 2's. Add 2. Okay? That means if we're adding 2, that is an arithmetic sequence. All right? And D, because we're in arithmetic, so we have a common difference of 2. Okay. D. Let's skip over to D for a second here. The D sequence. Let's see. 17 minus 10 would be 7. 10 minus 5 would be 5. Ooh, automatically we've got a problem here. 5 minus 2 would be 3. Okay, they do not come out the same every time. All right, let's try division. 17 divided by 10 would be 1.7. 10 divided by 5 would be 2. And 5 divided by 2 would be 2.5. None of those are the same. So subtracting going backwards through the sequence didn't help me. Division going backwards through the sequence didn't help me. So I can say that this sequence is neither arithmetic or geometric. But I do want to point out that the pattern was that each time, like this time I add 3, this time I add 5, this time I add 7, so the next time I'll add 9. So I know it's an adding pattern, but I'm not adding the same number every time, so it's not arithmetic. Okay, there's still a pattern. 26 plus 11 would be 37, plus 13 would be 50, but it is not adding the exact same number every time. Okay, E and F were tough, and they're ones that, guys, you got to type into a calculator. So let's look at E, and my calculator got cut off a little. Let me see if I can bring it back. Okay, good. This is the calculator work that I did for E. So I subtracted, I didn't start at the end, I confess. Okay, 7/4 minus 4, and I got negative 9/4. And then I did negative 1/2 minus 7/4, and I got negative 9/4 again. Then I got negative 11/4 minus negative 1/2. Now that's a lot of negative signs in there, and if you don't type these in correctly, then you're not going to get the negative 9/4 repetitively like you're supposed to. Okay, so the pattern is that I am subtracting 9/4 every time. Okay, subtract 9/4 for each term. Therefore, it is arithmetic, and D equals negative 9/4. Okay, so that's calculator work, guys. You got to do that on the calculator. You're not going to just look at those numbers and get it. You're going to have to do calculator work just like I did to figure out your D, see that it was the same. How do I know it's a D and not an R? How do I know it's arithmetic? Because I am subtracting every time to get those numbers. Adding and subtracting are arithmetic. A starts arithmetic and A starts the word add. Okay, same thing over with F. Okay, clearly these are not going to subtract to the same number every time. If I worked backwards through subtraction, I would not get the same number. So subtraction didn't work, so I tried division, and I worked backwards through them. Okay, so I did 123.4 divided by 1,234, and I got 0.1. Then I divided 12.34 divided by 123.4, and I got 0.1 again. Then I divided 1.234 divided by 12.34. And I got the same thing, 0.1. Okay? So therefore, the sequence, the pattern is multiply by 0.1. And since it's a multiply pattern, it is geometric. Geometrics have R, common ratio of 0.1. Okay, I'm going to put all the answers to these up right now so you can see like what the other terms in the sequence are. If you need to, pause so you can read them all. Because I'm going to scroll through this faster than you can read them, so pause if you need to. Okay, that's our video. Have a good day. See you next time.